So, as you may have noticed on our notes, we are having to review factor. So hopefully, guys have remembered algebra. I mean, we did it nonstop in algebra. So hopefully you remember a little bit about factoring, okay? I am going to be showing you a different way to think about it. Some of your teachers taught you this method, some did not. Most teachers taught with the X method. I am going to be teaching how most everyone before the current generation was taught to factor, and I was think about it, honestly. Like there's no method, it was just think about it. So that's what I'm going to be showing you because all higher maths pass pre-cal, that's how you do it. Just you have to think about it. But you can still use the X method. It works just fine. I just won't be showing the X from now on. All right, before we factor though, I think it's more useful to do this right hand. So what we're doing on this right hand side is we're taking factors and we are finding the original quadratic function from those factors. Does anyone remember how we do that? What do we do to this to combine these two binomials? Yes, you can think of it as FOILing, or I like to call it double distribution because that's really what it is. You're just distributing twice. So here, and I don't know why it stopped there, but here we need to distribute the x in the first binomial to everything in the second binomial. And then we also need to distribute the 3 in the first binomial to everything in the second. We're double distributing. So here we have x times x, x squared, x times 2, 3 times x, and 3 times 2. And then we just have to add the two middle terms to create e value. So 2 plus 3 is 5. Bring down the squared term and the constant. We're done. We have found the quadratic equation. Well, expression. And I know they say quadratic function. It only has one variable, so this is an expression. All right, I don't think that I really need to show you 2 and 3. Hopefully, at this point in your math career, you know how to multiply binomials. I will show you number 4 when it gets just a little tricky, just because the numbers are bigger. That's the only difference. So again, we're going to multiply the first term times both terms in the second binomial, and then you multiply the second term times both terms in the. So we have 7x, 7x, 49x squared, 7x times 10, 70x, and then we have negative 10 times 7x, negative 70x, and then negative 10 times 10, which is 100. Why am I struggling here? There we go. I was trying to change colors and there was no need at that point. Okay, so now notice our middle two terms, when we're trying to combine them into our b value, positive 70x minus 70x cancel, leaving us with 49x squared minus 100. Oh. So that being said, we're now going to go the other way and take the quadratic. So if we were looking at this first one, we're going to take the quadratic and factor to create our two binomials. Notice here that 2 and 3 multiplied to give you 6, but also added, multiplied to give you 6, added, yes? Oh, but then added to give you that middle b. So this is what we're going to be doing basically, is we're going to be thinking of two numbers that multiply to give us the c term, but also add to give us the B. So, oh, where did it go? So over here in this number one, we want two numbers that multiply to give us the last C term. Multiply, but add to give us B term. What two numbers multiply to give us B, but also add to by 2? Those are our factors, 3 and negative 1. And I'm done. This is just thinking about it, okay? We're actually doing what we've taught in previous years, you know, this A times B, so we have negative 3 and 2. What two numbers multiply to give you negative 3, but add to give you 2, and these are your factors. Well, we're doing all that, but we're not. Now, if we have an A term, so if we had a number in front of the x squared, on the x method, we would have to divide both sides by 2, right? We would have to do, I'm sorry, by the A value. We would have to divide them by the A value, and whichever one didn't simplify, we would have to pick it to the front of the x. So here, on this example, yes, you can do the x method, and if you're comfortable doing the x method, do it. I mean, it's a method that you can use, and it's totally useful. But if you weren't trying to use a method, instead we're just trying to think this, we know we're trying to factor this into 2 factors because it's an x. We know both of the leading terms are going to have x. Because to get this first term, it is an x squared. We are going to have to multiply an x times an x. We also have to think of factors of 4 that multiply together to give us, to go on those x. So what are factors of 4? 2 and 2. You could also do 4 and 1. We kind of have to guess here. The most commonly used ones are lower numbers. All right. So it's more common for you to get problems that factor using lower numbers versus a high. So instead of doing that one, we're going to guess and say it's 2 and 2. All right. Now it could be the 4 and 1. We won't know until we try, right? Until we try to find the actual answer. So here we put a 2 and a 2. Then we know that these two numbers need to multiply together to give us 15. So let's think of some factors of 15. Remembering that the smaller both numbers are, the better. We won't probably get a problem where it's 15 and 1, okay? 3 and 5. Now, it's negative 15. So there are 2 that we could possibly come across. Negative 5 and 3, or 5 and negative 3. So now is where the guessing comes into play. I'm going to guess 5 and negative 3. And you need to check. So we know that we need to end up with a b value that is negative 4. I am multiplying 2x times negative 3, and you get negative 6x. And you multiply 5 times 2x, and you get 10x. Well, what is 10x minus 6x? What is 10x minus 6x? 4x. Is that what we wanted? What are we trying to get b value? Negative 4x. So this does not work. Instead, let me try negative 5 and positive 3. So let's check. 2x times 3 is 6x. Negative 5 3x is negative 10x. Negative 10x plus 6x gives us negative 4. What we wanted? Yes. So this is our answer. So that's what I mean by just thinking about it. You're trying to have to just like run through the numbers and figure out which one works. And this is why I showed you the foiling, the double distribution first, because every single time you try to input numbers here, you're going to have to do this in your head. You're going to have to try to figure out, okay, do I end up with the trying to get to? If your answer is no, then you need to try other numbers. All right. So now let's go on to a different type of problem. How can we factor x minus 16? Square though? Did you say square? Yes. What do you know? They're both perfect squares and they're, Annie said it in the chat. Yes, difference of squares. Whenever you have perfect squares and there's a subtraction symbol between them, you can split them into two binomials, square rooting both terms. So the square root of x squared is x, and you write it twice. The square root of 16 is 4, write it twice. One's a plus, one's a minus, you're done. You're done. So knowing that, how would you factor? What is everything in this equation? Or, sorry, why is it 3? Right. Yeah. Everything is a perfect square. Everything is a perfect square, including the y square. Right? I can perfectly easily square root everything here. And it's a subtraction sign, meaning I can use the difference of squares form. So the square, oh, wait, no, go back. So square root of 1.4 is 12, write it twice. The square root of x squared is x twice. The square root of 25 is 20, write it twice. And the square root of y squared is y, write it twice. One's a plus, one's a minus. Done. I love it. The hardest part is recognizing that they're all perfect. That's the hardest. Any questions on any of these review problems? So again, in your head, this is probably the hardest one to do. Please, if you feel more comfortable doing this, do it. Okay? Find the A times, find the B, figure out which two numbers multiply to give you negative 60, but add negative 4. And then after you're done finding numbers, though, you do need to remember to divide by the A value. Okay. So now, here's why we needed to review that. We are now going to be factoring using trig functions. It is no different. We just all of a sudden have a different type of variable. All right. So if you see here in our first problem, it says sine squared of x. Anytime we're multiplying, this is just an important note. Anytime we're multiplying sine of x times sine of x, it's not sine of x squared. That's not how we write it. No, this is So here, this is sine squared of x. We don't write it as sine x squared because we're not actually squaring the x, right? This is not sine times x. It is sine of x. It's a totally different number. So we're not squaring the x, we're squaring the sine. We're squaring the trig function. So here, this first problem has sine squared of x, meaning we're squaring our first trig function. Then it has plus 2 times sine. This is just the normal trig function. And then there's a constant. If I want to factoring this, what is my first step? Yeah, have everything over x, right? It's always of the form ax squared plus bx plus c. We have to have everything on one side. So here we have sine of x plus 2 times sine of x plus 1. Now what? What do we have to think about? What two numbers multiply to be 1, but add to be 2? What two numbers multiply to be 1, but add to be 2? Yes, Dario, exactly. 1 and 1. 1 and 1 multiply to be 1, but add to be 2. So here, we know those are our two values, 1 and 1. They multiply to be 1, but add to be 2. But then our variable is actually a sine function. So it's sine of x, and we're done. If it's hard for you to, in your head, envision sine of x as a variable all in together, all together sine of x, if it's hard for you to envision that, what you can do instead is you can replace sine of x with a different variable. So what, and we did do this quadratic form a little bit in algebra 2 when we had functions, higher order variables in factoring polynomials. What we did was we substituted a variable for another variable that makes it into a quadratic. Right, it's just kind of weird looking. So that's what I'm saying. We can now make it look nicer if we want it to. What you do, first, you bring the 1 over, right? So it's 2 sine squared of x plus sine of x. Oops, 6 of x, sine of x, minus, right? We subtract the 1 over. Then what you can do is you can create a different variable that will replace sine of x. So I'll say a, I guess. We'll say that a will be in replacement of sine of x. So instead of writing sine of x, I will replace it with an a. So it becomes 2 times a, now this was the function squared. So it's 2 times a squared, the trig function, plus sine of x is now replaced with a, and then we bring down the minus 1. So see, that's so much simpler looking. That's easier to understand. We know how to factor this. This is a quadratic. This is a quadratic. So in our heads, now we think about what will multiply to give you 2 times negative 1, negative 2, but add to give you the 1. So what you do, create your binomials. You know that each one is going to have an a in front. And then we substitute really quickly. The only two numbers that go into 2 are 2 and 1, so I know it's going to be a 2 and a 1. And then the only numbers that would factor to give you negative 1 are negative 1 and 1. Whoops, not negative 1 and negative 1, just negative 1 and 1. Now here's the question. Which one, where am I going to put the negative one? So that in the end, my B term will be a positive 1A. Now don't write this. It's fun for you. If I put the negative one here and the one here, and I'm checking it, I know it's going to be 2A times negative 1, which is negative 2A. And then I know it's going to be 1 times 1A, which is a positive 1A. Negative 2A plus 1 gives us negative 1A. Is that what I wanted? No. This is not the correct positioning. Instead, negative 1 will go there and positive 1 will go there. Because when I check, 2A times 1 is 2A. Negative 1 times 1A is negative 1. So 2A minus 1A is a positive 1A. So this is correct. This is our factor. These are our factors. But of course, the last step, A was not what was originally in our original equation, right? We need to go back and replace A with sine of x. So this becomes 2 sine of x minus 1, sine of x plus 1. And I'm done. Those are my this making sense, sort of. I know that you guys haven't factored in a long time. You haven't factored in a long time, so I know that it's been out of your mind for a bit. And I also know that I'm throwing this just thinking questions at you, but I hope that it's becoming clear. And if you are confused, just know that you can always use the method, right? All right. So now what we're going to be doing, should I stop this recording?